All right, so in this question, number 43, we need to solve this rational equation. So what I did is I took this expression right here in 43, or this equation, and I factored the denominator. So we got x times x minus 3. All right, so there's a couple ways you could do this. You could get a common denominator by like multiplying this by x minus 3 over x minus 3, and multiplying this by x over x, and then just play with the numerators, because if all the denominators are the same, then you're dividing the same thing on both sides. You don't even have to worry about it. So that's one way you could do it. And you know what? Let's just do it that way. So maybe people like this way better, and I can show you another way just for time. So I did that, and I did that. And now we have 3 plus 4 times x minus 3 equals x. And this is over x times x minus 3, and this is over x times x minus 3. So another way I teach it is to multiply everything by the LCD. And if you were to do that here, if you were to multiply the left and the right side by x times x minus 3, like this would cancel out. So we're left with just this linear equation, 3 plus 4 times x minus 3 equals x. So I kind of did a hybrid of both things. You know, you could have just taken the least common multiple denominators and multiplied everything by that at the beginning, and you would have jumped right to this. Or you can get a common denominator and then just sort of set the numerators equal, because if you're dividing the same thing on both sides, right, it's like dividing both sides of an equation by 2 or multiplying both sides of the equation by 3. It doesn't change much. So, you know, they kind of just cancel out. And then we finish solving, and something interesting happens here. We get 4x minus 9 is equal to x. Bring the 9 over, subtract the x, divide by 3, and we get x is 3, which seems like it's a fine answer, but if you check the answer key here, it says it's an extraneous solution. So this is going to happen because there's domain restrictions with these expressions, right? You can't divide by 0 or 3. You can't divide by 0. You can't divide by 3. So when you're doing equations that have expressions in them that have domain restrictions, notice how those denominators disappear in the second step. So we're no longer accounting for those restrictions. So that's how it's possible to get a number like x is 3. But when we think about the original equation, it wouldn't work if we plug this back in, because we would get 0 as a denominator. So a rule of thumb for any equation, plug your answer back in, and if it works, it's a solution. If it doesn't work, then it's not a solution. So the only solution that we had didn't work, so we say that this has no solutions, and it's extraneous. And that could happen anytime we multiply both sides of an equation by a variable, like we did here. We multiply both sides of the equation by x and x minus 3, so it raised the degree. And when you raise the degree of an equation, you create extra solutions. Some of them don't work in the original equation. A very simple example would be something like x equals 1. All right, there's only one thing that works here, x equals 1. But if I square both sides, now x could be 1 or negative 1. This works in the original equation. This does not. So whenever you raise the degree of an equation, you have to know that there could be extraneous solutions. So number 43 has no solution. Does that make sense?